definition is the limit of f of x as x approaches a is equal to L. Let's apply that definition with an example. Given that f of x equals 7x minus 9, find the limit as x approaches 4. Here's how you set it up. And then you just want to plug 4 wherever there is an x. And then you find 7 times 4 minus 9, and this is equal to 19. So the limit of 7x minus 9 as x approaches 4 is 19. Let's graph this function. You know that the function 7x minus 9 is a line, and that the slope is 7, and that there is a y-intercept at 0, negative 9. After you trace a line, you notice that at the point x equals 4, the y value is 19, like we found previously. How do we know that a limit exists? We look at both sides and they have to match up, otherwise the limit does not exist. So a limit exists if the limit of f of x equals L as x approaches a from the right, and if the limit of f of x equals L as x approaches a from the left. The plus and minus sign near the a means from the left and from the right. If it's a plus sign, it means from the right, and if it's a negative sign, it means from the left. Let's look at this example. The limit of f of x as x approaches 1. You get two functions with specific limitations. You need to find the first limit when all the x values are smaller than 1, which means that it's 1 from the left, of x cubed minus 3x squared minus x plus 3. And then you just want to plug it 1 wherever there is an x. You find 0. Now, let's talk about infinite limits. The limit of f of x as x approaches a is equal to positive infinity, or the limit of f of x as x approaches a is equal to negative infinity. Let's look at this graph. You notice that there is a vertical asymptote at x equals 1. You want to test your limit from both sides to see if it exists. So, the limit of f of x as x approaches 1 from the left is equals to positive infinity. Then you want to test the right side, so you do the limit of f of x as x approaches 1 from the right is equal to infinity. Therefore, the limit of f of x as x approaches 1 is equal to positive infinity. You know there is a vertical asymptote when it's a number over 0. Let's look at this example. The limit of x squared plus 5 all over x plus 5 as x approaches negative 5 from the left. Since it's asking a value that is bigger than negative 5, because it's from the left, I would pick negative 5.001 and plug in wherever there is an x and look for what sign this is. So the top would be a positive sign, and the bottom would be a negative sign, which would make this limit going to negative infinity.
So a limit does not exist when one side doesn't match the other?
Let's look at the limit of 1 over x minus 1 as x goes to 1. First of all, you know that there is a vertical asymptote at x equals 1 because it's a number over 0. You then want to look at the limit from both sides of 1. So one from the left and one from the right. The limit of f of x as x approaches 1 from the left is equal to negative infinity. And the limit of f of x as x approaches 1 from the right is equal to positive infinity. These two do not match up, therefore the limit of f of x as x approaches 1 does not exist. You know there is a hole when it's 0 over 0. So let's look at this example. The limit of 4x minus 3 times x minus 3 all over x minus 3 as x approaches 3. So first of all, you want to plug 3 wherever there is an x, and you end up with 0 over 0. So you know there is a hole at x equals 3. You then want to simplify this, and you want to cancel out some things. So you end up with 4x minus 3. The limit of 4x minus 3 as x approaches 3, then you just plug 3 wherever there is an x, so it's 12 minus 3, and then you get 9. So the limit of 4x minus 3 as x approaches 3 is equal to 9. Let's look at some practice problems. For the first problem, you find out that it's 0 over 0, which means there's a hole at x equals 3. And then you want to clean it up and simplify and cancel some things out, and you find 1 over 3x. And then you just want to plug in 3 wherever there is an x, and you find 1 over 9. For number 2, you plug in 3, and then you find out that it's 1 over 0, so there is a vertical asymptote at x equals 3. You want to clean it up a little bit and cancel some things out, and then you find 5x squared plus 3, and you want to plug in 3 wherever there is an x. So it's 5 times 9 plus 3, which is equal to 48. In number 3, when you first plug in 3, you get 2 over 0, so you know that there is a vertical asymptote at x equals 3. You then want to test the limit from both sides, so 3 from the left and 3 from the right. You then want to look at the signs and figure out which infinity it is. So for the first part, you got like 3 from the left, you get positive infinity because it's a positive sign over a positive sign. And then for 3 from the right, you get a positive sign over a positive sign, which is also positive infinity. Therefore, the limit of f of x as x approaches 3 is equal to positive infinity.
The first function, 3x squared plus 5, asks for values that are smaller than 3. So you want to test your limit from the values that are from the left of 3, so smaller than 3. So then you get the limit of 3x squared plus 5 as x approaches 3 from the left, and then you plug in 3. So 3 times 9 plus 5 equals 32. Then the second limit asks for x values that are bigger or equal to 3. So 3 from the right, so the limit of negative 3x squared minus 5 as x approaches 3 from the right, then you plug in, and then you get negative 32. However, both sides of the limit are not equal because you find negative 32 and positive 32, therefore the limit does not exist. And finally, some things to remember is, when you find something that is 0 over 0, it means that there is a hole. When you find a number over 0, it means that there is a vertical asymptote. And finally, to see if a limit exists, you should check both sides and see if they match up.
Thank you for watching!